So I'd like to start with a demo of Chiasm actually working in Chorus. Here's the iris dataset as like an example dataset in my local Chorus. And when I click visualize, I get a bar chart. Oh, the resolution. Oh, geez. Anyway, if I click down here, it actually calls into the code that produces the aggregations for the bar chart with SQL on a database and passes the result into this visualization, which is an instance of Chiasm. So it's just Chiasm configured with one visualization, which is a bar chart. And it shows that Chiasm is bundled and packaged into the Rails asset pipeline, which was really tricky to get working. And it's actually running inside of the Chorus Rails application. So what I'd like to really talk about today is the Chiasm project and how it works internally and how it's set up internally. So this highlighted in red part here is the optic chiasm in a human brain. So this is what the word chiasm really means. And I have sort of taken it to mean it's this like intersection between data systems and data visualizations. So that's why it's called chiasm. And yeah, that's the idea. So in our case, Chiasm sits in between our big data stack with Hadoop and Spark and Scala and SQL. And Chiasm has a unique relationship with D3. Chiasm plugins are written using D3. So Chiasm is kind of leveraging D3. And so, yeah, Chiasm should bridge the gap between the world of all this data processing and the world of visualizations. So here's some just example visualizations that Chiasm should be able to enable. So the way that Chiasm works is it takes as input a configuration and it gives you as output visualizations. And there's some magic that happens in Chiasm to transform the configuration into running interactive visualizations. And a more detailed picture of that looks like this. When the configuration changes, the Chiasm runtime detects those changes. And those changes could include like creating a visualization component, and the configuration specifies a plugin that should be used to create a component and the state of that component. So
are these plugins the actual charts that you're trying to do?
So yeah, there would be a plugin, for example, for BarChart and Scatterplot, and another plugin for loading data from a CSV file. And then the configuration will instantiate, well, the configuration, when it's loaded, will cause Chiasm to invoke these plugins. And these plugins are essentially constructor functions for components. So like in this example, like this plugin may create 3 different components. So a component in this terminology is an instance of a plugin that is managed by Chiasm. And so as the configuration changes, Chiasm will update the set of components. And then as the components change, like let's say you interact with one of these components, that interaction, if it changes the state of the component, it will propagate that change back into the configuration. So that means this configuration will change over time. And then you can serialize this configuration, like save it to a file, and then load it up later. And then you'll get the same state back that the user created by interacting with the charts. So for a more specific example, here's a Chiasm configuration on the right. This right here is the generic structure of a Chiasm configuration in sort of my own made up type language for JavaScript objects. So the configuration keys are aliases. So in this case, layout is an alias, BarChart is an alias, BarChart CSV loader, and links. These are all aliases. They're just arbitrary names that are assigned to components. And so an alias points to an object that has as one property a plugin, which is a string. So in like layout is an instance of the layout plugin. So the naming is a little confusing. This is the plugin name. This is the alias of the component. And a lot of the times they'll be the same. But if you want to have multiple components that use the same plugin, then the aliases will have to be different. So yeah, the plugin string tells Chiasm like which plugin to load. And then there's a state property on each alias. And that state is, property value mappings, like key value pairs that specify the state of the component. So let's go through this this configuration completely. So the layout plugin is responsible for bridging the gap between like the DOM, the document object model of the web page, and this world of components. So layout, it does nested box layout, so you can specify like there's a box, and then inside that box there's two visualizations, and maybe in one of those boxes there's two more. So it has this nested box layout plugin. But this is sort of a degenerate case where there's only one visualization. So this is just what it looks like to instantiate the layout for one visualization. How would you do two? So I have an example that I can show you that has two. So this is the Chiasm kitchen sink. It just sort of scrolls through these different examples. So I just wanted to show you that here's what it might look like if you had two visualizations. The layout, the root of the layout is an object that has an orientation property and a children property. And then, so in this case, editor is this text editor on the left. And then on the right, there's this nested structure with a vertical split, where on the top it's the bar chart and on the bottom is the line chart. So this is how you would specify a layout for multiple, in this case, 3 components. So yeah, the bar chart component has a state where the properties are conventions. Like these properties will appear on many visualizations. Like X column is letter. In this case, it's the column name of the CSV file that you want to map to the x-axis, which in this case is bars, like ABC, different letters. And then the x-axis label is the human readable thing that will appear to the user. So I'm making that a different property than the column name, because usually the column names are not like human readable. And the same thing for Y. And then you can give it a title, and the title text just appears at the top. Here there's a CSV loader component that's instantiated to point to this path, simple bars.csv, and then it has a listing of which columns are numeric, like which columns should be parsed from strings into numbers as a preprocessing step. So this is just a generic, simple CSV file loader. And so in integrations with bigger systems like Chorus or other systems, this part would be replaced with a different plugin that would call into the system-specific data loading functionality. But this is just a simple example where it loads a CSV file. And then there's another generic plugin called links that will propagate changes from one component to other components. And this is a very, very generic thing. This can be used later on to specify linked views. But right now it's just specifying that when the CSV file loads, then pass that data into the bar chart. And this is a little domain-specific language with an arrow that is just parsed with like alias dot property value goes to alias dot property value. So this is like the simplest possible Chiasm configuration that loads some data and makes a bar chart. So the way that Chiasm interprets configuration files is that there's an initial configuration, which is an empty object, and then Chiasm processes only configuration differences and takes those differences and executes them. So there's an algorithm in Chiasm that computes a difference between two configurations, and the result of that difference is a sequence of actions, an array, an ordered list of action objects. And these are the 4 different types of action objects that exist in Chiasm. You can create a component, and when you create a component, you need to give it an alias, which is just an arbitrary name for that component, and then a plugin, which is a string that tells Chiasm which plugin to load. And then after you've created a component, you can set properties on it by referring to it by its alias and setting, which property to set and which value to set to that property. Create and set are usually all you need to instantiate a configuration. But as a configuration changes over time, like let's say you add a bar chart and then you remove a bar chart, destroy alias will destroy that component. Or if you want to support undo redo, you can unset a property, which will reset it back to its default value. So every property that's configurable within Chiasm has a default value. And unset is the opposite of set. So like if you call set and then you call unset, it just resets that property to its default value. And then destroy alias will destroy that component. So this is, you can do like full lifecycle management.
Set to default value, or is the previous value?
When you call unset, the default value, it's not the previous value.
The onset sounds like you're setting to null.
Yeah, that's a great idea. Yeah, I named it unset because it's kind of the opposite of set, but yeah, maybe you're right. Maybe it should have a different name. I mean, this is all in flux. That's a great suggestion. Maybe like reset default, revert. Yeah. So why is it architected like this, where it processes only the diffs between configurations? There are two sort of futuristic features that this architecture enables. One of them is undo redo. So in this diagram, each of these circles is a state of the whole application, pretty much a configuration, a Chiasm configuration. And then when you make a change to the configuration, you can model that as, well, an array of actions that will transition you from one state to the other state. And then when you do that transition, you can compute the array of actions that will get you back to the previous state. And then you can store those as like do and undo in some kind of graph data structure. So this would support history graphs like this, where you start here, you do a bunch of actions, and then you can undo and go back, and then maybe start doing another set of actions from a previous state. So I want to enable, history graph navigation with this architecture.
Like, I guess where is this
So each of these states is a configuration. You can think about it as though there's a whole complete configuration JSON structure stored at each of these nodes. But what you can do is really only store the differences in the edges of the graph, sort of like how Git works, where it only stores the diffs. But yeah, conceptually, each one of these nodes contains an entire Chiasm state that can be reconstructed by traversing the edges of this graph. Well, actually, this is not implemented yet at all. But it's just to explain why I organized Chiasm as like processing these set and unset actions. It's to anticipate this feature. So I haven't implemented this yet, but I want to implement this in the future.
Part of the idea is to store these as objects in Chorus. Then
right.
How do we version? How do we do undo redo?
Yeah.
Where is it stored?
Right. So I think initially when we do the saving integration in Chorus, it will just save the configuration. But maybe in a future iteration, it will store the entire history graph. So maybe when you open up, you can open up, instead of a Chiasm configuration, it would be a Chiasm session where you would see this whole history graph and be able to click on each node and restore the state on each node. That would be awesome. Yeah, you could actually have a diagram like this where each of these could be a screenshot at that state. I think that would be super cool. A session would contain this whole history graph, and then you would persist that session, then you can open it up later and add more nodes to it and then save it. So yeah, it would be a lot like revision control, a lot like Git. And another feature I want to enable with this architecture is real-time synchronization between many clients like Google Docs. So let's say you instantiate a Chiasm session, and then multiple clients could connect to that session. And then if changes are made in one client, that sort of change packet as like the do array of actions could be broadcast to the server, and then the server could broadcast that to all the other clients, and then it could be executed on the client systems. And there's a technology called share.js that implements this kind of synchronization, and I think we could leverage that in the future to build out this functionality. But this would be super cool, where you could have like real-time collaboration on visualizations. So if you change the color of a bar chart or something, that would like instantly propagate to all the other people viewing. So undo, redo, and real-time synchronization, this is why I organized Chiasm like this, based on these configuration diffs. I want to talk about now the state of things with regard to plugins, and also how it relates with Chorus and bundling. So this is the dependency graph of JavaScript modules that are used in Chiasm right now. And so what you saw earlier in the Chorus demo is the Chiasm bundle So when you click on this, when you click on this, it calls into the SQL database, computes the aggregations. Right. So what's happening is Chiasm is being bundled into one massive JavaScript file, and then it's being integrated into the Rails asset pipeline of Chorus. And so that's what you're seeing there. But the Chiasm bundle, so this has been a nightmare that I've been struggling with for a while because of the tooling involved with bundling JavaScript files. So ideally, Chiasm should just be the core runtime environment that doesn't contain any plugins at all. That's what I want to have. And then I want to have each of these plugins, so like the layout plugin, the CSV loader plugin, the links plugin that just transfers values from one component to another, the dummy viz component, which is just a fake visualization with an X going across the screen, and then there's scatterplot, bar chart, and line chart, which all use this component called reactive viz, which is like implementations of reusable visualization patterns like axes and things. And then reactive viz depends on model.js, which is an open source library I created before, and D3. So right now, all of these modules are AMD modules. So AMD means asynchronous module definition. It's just a way of making JavaScript modules that can encode their dependencies on other modules. These are currently all files in the plugins directory of the Chiasm project. And while we're discussing that, why don't I just show you, I do want to briefly overview, so this is the Chiasm open source repository on GitHub. It's got an extensive README and a bunch of examples. And then there's a kitchen sink directory, which contains a bunch of Chiasm configuration files. And you can run the Chiasm kitchen sink demo by clicking on this picture. And this is what the Chiasm kitchen sink demo is. It just loads in all these different configurations and shows that it's possible to dynamically change the configuration. And all it's picking up is diffs. And you can sort of prove that it's not tearing down and reconstructing the visualization with these examples that have transitions. Like if it were tearing down and recreating the visualization, it wouldn't have this transition behavior. It couldn't. So it's just sort of to prove that it's just computing the diffs. So that's the Chiasm kitchen sink. And then in the source directory, it looks like this. There's chiasm.js, which is just the runtime that loads up configurations and computes the diffs. And then there's a plugins subdirectory, and each one of these is a plugin. So let's just take a look at dummy viz. This define is AMD syntax. It says I'm defining a module that depends on D3 and model.js. And then I'm creating a model that has these public properties that can be changed in the configuration. And then here it's just building up the DOM, the document object model structure based on the configuration. And model.when responds to changes in the configuration. So like when the color changes, update the fill attribute on the rectangle. So this is sort of an overview of how the plugins work. But ideally, this plugins directory would not exist. So currently, these are all AMD modules in the plugins directory. But in an ideal world, I think they should really all be separate repositories. And there should be a real plugin system. So a real plugin architecture. So what I view as a plugin architecture is anyone who wants to use this architecture should be able to do these following 4 tasks. They should be able to use a plugin that somebody else made. They should be able to create a plugin. They should be able to test a plugin, as in like write unit tests and run the unit tests. And then they should be able to bundle an application that uses many plugins into one massive file so it can be integrated into production flows like the Rails asset pipeline. And so there's a wilderness of tools. So like I'm currently struggling to figure out which tools to use. So let me just give an overview of all these different tools. So there are a few package managers. So you guys are in the Java Scala world. So like Maven is the package manager that you guys know. And then in Ruby, there's like Ruby Gems, right? Or Ruby, I don't even know. So in the JavaScript world, there are similar things. There's NPM, which is the Node package manager. This is a massive community, and let me just show you, like, it's really professional. This is the npm package manager, and here are some of the popular packages. There are 151,000 packages in npm. npm has become the de facto standard for JavaScript packages, and so these packages are authored in CommonJS, which is not AMD. It's a different module format. And it was started for Node.js, but then there's this other thing called Browserify that lets you use Node modules in the browser. And this seems to be a very popular option of all the different options that we can consider. So npm and Browserify kind of go together if we're going to choose this for our client-side project, because we would need to use Browserify to do the bundling and the loading into the client. There's another set of tools that I'm using now, which is Bower and Require.js. So Bower is a package manager that's a lot like npm, and it was created by Twitter. And Bower pulls from a GitHub repository when you install a package. And so you can do like Bower install some package and then a version, and then it installs from GitHub the particular version that you request. So I'm just going to make a temporary directory and say Bower install model. So I published model.js with Bower. And when you do this Bower install, then you get a directory called Bower components. And there's nothing in there now except model. Right, it's a registry. There is a central searchable Bower registry, similar to npm, where there's billions of modules that have been published there. And Require.js is an AMD module loader, and Require.js also contains an optimization program that will bundle AMD modules into a single big file. Then there's JSPM and System.js. This is a more new thing that is future-looking based on ES6, which is ECMAScript 6. It's like the next version of the JavaScript language. So if we were to adopt this technology, then it would be like future-proofing our whole flow. And it would enable people to write Chiasm plugins as ES6 modules, which is the upcoming standard that sort of resolves all the problems that are the cause of the existence of these other things. And then there's testing frameworks, like we're using Jasmine and Chorus, and currently I'm using Mocha as the unit test framework for Chiasm. And then there's a task automation. So like GNU Make is the sort of prototypical task automator thing. And then in the JavaScript world, for many years, Grunt was popular, and now it's been replaced by Gulp. So this is the current strategy with Chiasm. Bower, Require.js, Mocha, and Gulp. And here's what the flow looks like for creating a plugin and using a plugin using this strategy, these tools. So to create a plugin for Chiasm, I haven't done it yet. Right now, they're all files in the plugin subdirectory. But this is sort of the next horizon. Like, how do you really make it possible to make plugins and use plugins that are based on Git repositories? So all of these would be separate repositories, but then there's a Chiasm bundle, and actually I'm calling it VisEngine. Right now the Chiasm bundling is in the VisEngine project. So what this does is it installs, right now it uses the Chiasm subdirectory, but what this project would do is install all the plugins, pull them all from the remote repositories, and then bundle them all together into one file. And that one file would be what Chorus is using that contains all the plugins. So it wouldn't be like dynamically fetching the plugins. It would all be bundled. I would ideally like to dynamically fetch the plugins, but it seems like bundling is the preferred strategy right now. So this tooling is all like pre-bundling. It's like, how do you get all the plugins in one place and then bundle them together? But ideally, anyone should be able to author their own plugin independently of like asking me to add a file into the subdirectory in the Chiasm project, and that would enable growth. And I want to also talk about Gulp. So Gulp is this build system, and Gulp is very similar to Chiasm because it's based on plugins. You have a Gulp task, and it's based on this piping strategy or streams, node streams. But that's not really what I want to highlight. What I want to highlight is on NPM, if you search for gulp, you get this massive list of gulp plugins. And the convention is to prefix your package name with gulp dash. So gulp is like the core system that doesn't have any plugins. And then all these other projects are gulp plugins, like gulp util, gulp rename, gulp less, gulp, JS hint, which does like syntax checking for JavaScript. So this is the pattern that I want to implement with Chiasm, where Chiasm should be like a top level package, and then other packages would be like Chiasm dash something, like Chiasm dash BarChart or Chiasm dash, crazy map. Donut, yeah, Chiasm dash donut. You can make that one. Yeah. Right. So the process for making plugins with this current toolchain would look like this: create a GitHub repository, tag a release of it, and then publish the module to Bower. And then to use a plugin, you would add a Bower dependency to your project, which will pull in those files. Modify your require.js config. So require.js is the thing that loads AMD modules, and so you need to just tell AMD. So in a Chiasm config, you have plugin is BarChart, right? So how does Chiasm know that the string BarChart should load in that particular file? That is through this require.js config file. It just this config, it matches strings to like full paths of the modules. So this is how Chiasm knows where to look for those modules. And then the last step for using a plugin is to modify the Chiasm config file to use that plugin. And so the things in red are the steps that I think could be eliminated if we switch to this other strategy, which is JSPM and the System.js module loader. And I'm not 100% sure if we're going to even go in this direction, but it's like something I've been considering. Yeah. Yeah, publishing to Bower. Oh, it's like Bower. It's a command. Anyone can publish to Bower. There's no moderation. Yeah. Right. Exactly. It's like it's a free for all Wild West namespace where you can say Bower so I took the name model. That's my like claim to fame. Yeah, model. That's like a fundamental name, right? But in NPM, I wasn't so fortunate. There's already a component called model. There's another component called model.js, and then there's model-js. They're all already taken in NPM. So Bower is a less used repository than NPM. It's for client-side stuff. But yeah, to publish to Bower, you just need to say like Bower publish or something. So it's just a command line thing. And then Bower will look at your GitHub repository and the tags, and it will take the most recent tag and install that if you don't specify a tag. Right. So Bower also deals with dependency management. So if one Bower package depends on other Bower packages, then when you Bower install the first package, then Bower will install the dependency packages for you. But it won't configure the require.js loader to look in the right place for the dependencies. So you have this extra step of modifying the require.js config, and it's a nightmare to deal with bundling in require.js in my experience, because you have to do some like it's really finicky with how it does the bundling and resolves the paths and relative paths, things like that. So these are the problems that I see with the current tooling. So I've been doing a lot of research into this other package manager called JSPM and System.js, which is a module loader that's akin to require.js. And System.js can load AMD modules and CommonJS modules and ES6 modules, which is the future JavaScript modules. So using System.js and JSPM, this is what the flow would look like for creating and using plugins. You just have to create a GitHub repository and tag a release. And use the JSPM. Oh, I didn't include it, but you need to use the JSPM command line to like initialize your project. And then when you use a plugin, all you should have to do is modify the Chiasm configuration. And then if we use, so JSPM has a specific string format to define like where the package gets installed from. And if we use that string as the plugin string in Chiasm, then there could be like a pre-processing step, like an automated step that says like install dependencies based on the Chiasm config. and then it will use JSPM to fetch those modules locally. And then JSPM also does bundling. So you can use JSPM to bundle everything and then include that bundle into the Rails asset pipeline. So this is where I'd like to go. I can also show you, like, there's this thing called Viz Engine, which is a Rails engine that's a plugin for Chorus, and it gets mounted. And this contains as a Git submodules. Oh, I haven't committed that, but it has as a subdirectory. Oh, it's in non-Rails. So there's a non. So yeah, this directory structure is dictated by Rails, and I found it like a little bit cluttered, So I just created my. I mean, it's just all these files. So I have this subdirectory called non-Rails, which is where I'm doing my work. So there's a Chiasm subdirectory, which is a Git submodule that includes the whole Chiasm project. And then here, there's the Chiasm bundle, which is a top-level thing that just requires all the plugins. So this triggers the bundler to include all the plugins into the bundle. And this is not ideal. This should be automated. Like, I shouldn't have to type these things. This is one thing I've been struggling with that these other tools would help out with. And then there's a data reduction service, which is using Spark Job Server. And this is the Spark code that I wrote that computes aggregations. And it works. Like, I showed a demo before where you can click on a field to aggregate by for a bar chart, and it will use Spark to do the computation. So we need to set up this infrastructure with like Spark Job Server running on a machine, and then this code being deployed to that Spark Job Server, and then the Rails. Oh yeah, I should show in the yeah. There's an implementation of a Rails controller that sort of forwards requests to the Spark Job Server and gets the results back through a REST API. So this is the other sort of avenue of work. Yeah. Yeah, so is the diff done in Model.js or Chiasm? So each component here is an instance of Model.js. So each component is one of these reactive models. So if you change the state, then Model.js will manage the internal propagation of changes for dependent properties within each component. But Chiasm deals with externally to the component. When the configuration changes, it detects, because there's a function in Chiasm called like compute config diff, where you give it an old config and a new config, and it will generate this array of action objects. And then for each action object that is a create, it will invoke the plugin which creates an instance of model.js. And then when it executes a set action, it will set that property on the model.js instance. And so in the example of the bar chart, if it sets like the column, or in the example of a scatter plot, if it sets the property that is like the x-axis column, then so that's where Chiasm ends. Chiasm just sets that property, and then where Model.js responsibilities begin is in propagating that change through the system and actually rendering the right data. And so that propagates internally to the chart. Yeah. So Model.js is like internal to charts, and Chiasm is this like packaging around the components. Yeah. Any other questions? Yeah. Oh yeah, how to write a plugin. Yeah, definitely. So actually, in the Chiasm project, there's a wiki page, how to create a plugin. And so this is like just sort of a first draft, but it explains that like, yeah, you make a module and you return an instance of Model.js. And there's this public properties concept, because with Chiasm, in order to support like undo, like unset, public properties, as in like the properties that can be configured, need to have a default value. And if they don't, the behavior is undefined when you unset a property. So this is enforced. So you need to create a public properties array, and then each property in that array needs to have a default value. and I'm using model.none for optional properties. This is similar to Scala's option type. And so here's an example that uses, actually, what is this? Oh yeah, so here's an example of a plugin that uses the DOM. It constructs a text area in the DOM, and then you need to implement destroy, which will clean up after itself. So this is what a complete plugin looks like. This is the simplest possible complete plugin for Chiasm that uses the DOM. Yeah, so this is like the guide so far. And then from here, there's the dummy viz plugin. That's like an example, a more full example of a plugin. Oh yeah, the BarChart plugin is there. Oh yeah. Right. So from that wiki page, I could link to the dummy viz and then to the BarChart example. Here's what the BarChart looks like. It's a module, and it returns the model, and it implements destroy, just like in the dummy example. And it uses reactiviz. So it depends on the reactiviz module, and then it uses reactiviz to implement the scales and the axes. And then here's the code that renders the bars. And so it's similar with scatterplot and line chart and everything else. Yeah. Oh, and reactiviz should definitely be its own separate whole project. Like right now, it's not even a plugin, it's a dependency of several plugins. Yeah, I wrote this reactiviz. This is also from my PhD thesis. And I want to build this out into its own separate open source project. Yeah. So thank you.